Hi, welcome. So we have got a question here in circles, and let me quickly share my screen so that we can start the discussion on that. Yeah, so here we are. All right. So we start, and the question which we have says that if there is an angle which is subtended by an arc, so they are basically talking about an arc in this question, and this arc is subtending an angle on the center of the at the center of the circle. So what does it really mean is we need to just see. Let's quickly mark this here, and this is the suppose center, and there is an arc, and say the arc is this. Okay, so we have this as arc, and we can name it as A, and then say this is B. Now this arc AB, the question is saying that this arc AB is subtending an angle at the center. So meaning of the subtending an angle at the center means the arc is forming an angle at the center, right? This is the angle which arc is forming at the center, or we can say the arc is subtending at the center. Now, it is also saying that this angle is double the angle which is subtended by the same arc at any point on the remaining part of the circle. So at any point on the remaining part of this circle, right? So let's consider that this is the, you know, that any point which they are referring, this any point, okay, on the remaining part of the circle. So it has to be on this part of the circle, right? Now, let's see how this arc is forming the angle at this particular point. And say, suppose this is C. So it will form the angle like this. Let's connect, you know, A with C. And then we will also connect C with B. Now, what they are saying is that this is also an angle. And what we need to prove is that the angle, and suppose this is, center of the circle, and we can name it as O. So what we need to prove is that angle AOB is double the angle ACB, right? Basically, what they're saying is the angle subtended at the arc. So this is the angle which is subtended at the arc, at the subtended by the arc at the center. This is the angle, right? So this is subtended at the center. Now, this is double the angle subtended by the arc at any point on the remaining part of the circle. So the same arc AB is basically forming one more angle at point C on the remaining part of the circle. And the relationship between these two is this. And this is what we need to prove. So this is to be proven. Okay. So we'll start with this. And first thing is that we connect O with C, right? So here we've connected this, and this is then extended further. Okay, and yeah, so we'll just remove this. Yeah, so and let's sort of name this as P. Okay, or we can name it as D. So this is D. All right. So now what we do is we will, we will consider this. We'll check out this angle DOB. So we have angle DOB equals to the sum of, we know that, this is angle DOB, right? We can quickly see, you can see this is angle DOB, right? Now this is nothing but the exterior angle, all right? Now we know that the exterior angle of a triangle is always equal to the sum of the opposite interior angles, right? So if we check out the opposite interior angles to this particular exterior angle, then we'll see that these are the two opposite interior angles of this exterior angle. So what we can say is that angle DOB is equal to, we can write that angle DOB is equal to angle OCB, OCB plus angle OBC, right? And at the same point of time, what we also understand is that these two sides are equal to each other, because they being the radii of the same circle, they would be each other. So if they are each equal to each other, then that means these two angles, this angle is equal to this angle, right? So that means these two angles are basically equal to each other. So what we can write is that this is angle OCB, plus we can write this also as angle OCB. And finally, what we can write is that angle DOB is equal to twice angle OCB, right? So this is our DOB, and we got this, like, this is equal to twice of angle OCB. Now let's just mark it as equation number 1 here, right? So this we considered in the triangle DOB. This we considered in the triangle COB, sorry, in triangle COB. And now let us consider the other triangle, the other one, like, right? So this we can write as COA, in triangle COA. And here we will consider this particular exterior angle. And for this, these are the two angles, this one and this one. These are the two interior angles whose sum would be equal to this particular exterior angle. So what we can write is that angle AOD, right? We can write this, that angle AOD is equal to the sum of this one and this one. So then what we can write is angle ACO plus angle OAC, right? And as we found in this particular triangle, that these two sides were equal to each other, because they being the radius of the same circle, they would be equal to each other. Similarly, this side and this side, basically OC is equal to OA, right? And if that is equal to each other, then that means these angles are also equal to each other, because then they are isosceles triangles. So what we can write is as angle AOD is equal to angle twice of angle ACO, right? So this is how we have now got. Now this is the equation number 2, suppose. So we have finally got two equations, and now we will sum them up, both the equations. So what we will get is, we'll add up angle DOB plus angle AOD, right? So let's sum them up, and we can then write angle DOB plus angle AOD is equal to this thing. So that's like twice angle OCB plus twice of angle ACO, right? Now, if we look at the diagram, then we can write that these two angles, DOB and AOD, is equal to, is nothing but this part, right? This and this. So this we can write as angle AOB. So what we'll write is AOB is equal to, we take the 2 as common from here, and then we can write angle OCB plus angle ACO. We can also then write that, if we check out these two angles, right, then we will check out that, the sum of these two angles is nothing but this one, right? So we can simply add them, and we can then write as, angle ACB. So this is how we have established our relationship that angle AOB is equal to the double of angle ACB, right? And this is, yes, finally got it right. And angle AOB is nothing but the angle subtended at the center, and this is subtended at any point on the remaining circle, right? So I hope you guys enjoyed it and could understand also. And please keep watching these videos. You can follow this page. You can also put your comments into the box asking for any clarifications or doubts. And I'll be coming up with more videos for the entire book of 9th and also for the grade 10th. Thank you so much. Have a nice day and bye bye.